again I am repeating, the ligands of a complex are named in the order of negative ligand, then neutral, then positive. It means if there is a combination of different type of ligand, negative ligand is there, neutral is also, positive is also, then first of all we select which ligand is a negative, we write down this, and if there is a positive also and neutral also, then in the second thing we write down neutral, and at the last positive ligand, and after writing the name of a ligand we write down name of the metal atom, and after this we write down oxidation state. For next rule is the prefixes mono, di, tri, tetra, penta, hexa, etc. These things and these prefixes are only limited for the ligands, number of ligands, because if there is one ligand then we write down mono, if there are two ligand we write down di, then tri for the 3, tetra for 4, penta for 5, hexa for 6. Similar oxidation state of a metal atom is shown by the Roman number. In the first step, if we want to write down the name of our UPSC nomenclature of inorganic compound, first of all in the first step we have to select the central metal atom. Suppose example is given potassium, hexaferrocyanoferrate 3. K4 FeCN6 mostly we are used in laboratory in our daily routine in the lab, first year, second year, as well as BSc also. First of all in this example we have to detect which thing is behaving as a metal, just like as potassium is there, iron is there, cyanide is there, but it means there are 3 different species are there. Out of 3 different species, iron is the metal atom. First of all select the iron metal atom, then calculate the oxidation state. It is too much important because without calculating oxidation state we cannot do anything. For example, it is K4. In which style we have to calculate oxidation state, I am doing here. But first of all, if you want to practice, then you can also use the first year book. It is too much important and very easy. If you cannot do, then first of all go back and revise the first year oxidation state. In the first year book, in the 7th chapter, there are different examples are there. KMnO4, K2Cr2, 7KCrO4, different oxidation state are example there. First of all do practice all these things, then you do in the complexes. K4, and in this style you will do I am doing K, then iron, then Cn, these, and then 0, because there is no charge on the overall molecule. Potassium 4 molecules are there. In the second step write down the number of atoms, how many are given in this example in this complex. Cyanide are 6 molecules. We know potassium has, because mostly we calculate the oxidation state of metal, that's why we should know the other oxidation state of the other molecule, otherwise we cannot easily calculate. Potassium has +1 oxidation state, iron we don't know, cyanide has -1 oxidation state. +4, it should be +4, iron plus minus minus 6, 0. It is simple calculation and the maths students know very well, but every step I am doing only because of you. If you have a practice, then directly you can do, but directly you shouldn't do. You should have a practice, and every step you do as a rough column at the corner of your copy. I have done. If you are looking on a board, the oxidation state of iron is, which we have calculated, is +2. Plus sign is very much important. You can't skip to write down it. We know very well if something is not written, it means it is a positive value. But in the case of oxidation state, in the case of charges, cationic, anionic, then plus minus charge are very important, and we have to show. Then it is a +2.